You ever notice how some things in life just seem to move in perfect sync? Like you work twice the hours, you get paid twice as much. Or you decide to run 3 times farther and, yep, it takes you pretty much 3 times as long. Well, today we're going to put a name and some really simple math to that exact kind of perfect relationship.
Here's a perfect way to think about it. If you double the recipe, you double the flour. Come on, we've all been there, right? You're in the kitchen, you need to make more cookies for friends, so what do? You just double everything. This idea, this perfect scaling that we all just kind of know how to do, is exactly what we're talking about today. It's a proportional relationship at its heart.
So that leads to the question, what's actually going on under the hood? What's the real math behind this everyday thing where if one thing changes, another thing changes by the exact same amount?
And here's the name for it. That perfect sync is called direct variation. I know it sounds a little formal, maybe a little intimidating, but all it really means is that two things are directly tied together. If one of them doubles, the other one doubles. If one gets cut in half, the other gets cut in half too. They just scale together perfectly. And this is the simple but really powerful little rule that's behind it all. Y equals k times x. Now, don't let the letters freak you out. Just think of x as your input, like how many hours you work, and y as your output, how much money you earn. And they're connected by that special little letter in the middle, k.
So what is this mysterious k? Well, it's pretty much the star of the show. It's called the constant of proportionality, and it's the one single number that defines the entire relationship. For that job we mentioned, k is just your hourly wage. For the cookie recipe, k is how many cups of flour you need for one batch. It's always the constant ratio of y divided by x.
I actually love thinking about it this way. K is like the secret code for the relationship. If you can figure out what K is, you've basically cracked the code for that whole situation. Once you know it, you can predict any Y for any X. It's the key that just unlocks everything.
Okay, so theory is one thing, but how do we actually spot one of these relationships out in the real world? Like, if you're just given a bunch of data, how can you be sure it's a true direct variation? Well, let's put on our detective hats for a second.
All right, let's check out our first piece of evidence. We've got a simple table here with some x and y values. And yeah, we can see that as x gets bigger, y is getting bigger too. But is it proportional? Is there a secret code, a k value, that's the same for every single one of these pairs? This is exactly how we're going to figure it out. We're going to use something called the ratio test. And honestly, it's super straightforward. We're just going to calculate the ratio of y divided by x for each pair and see if we get the same number every time. If we do, it's a match.
So let's try it out. We'll grab that first pair from the table where x is 2 and y is 6. To find our potential k, we just calculate y divided by x. So that's 6 divided by 2, and that gives us 3. Okay.
Now that's just one data point. The key word here is constant, so we have to check another pair to be sure this isn't a fluke. Let's try the second row. Y is 12, x is 4. So what's 12 divided by 4? It's also 3.
This is looking really good.
And there we go. Since that ratio is the same for every pair in our table, we've found it. The secret code is 3. This is absolutely a direct variation, and now we can write its exact equation, y equals 3x. And with this simple rule, we can figure out what y would be for any value of x.
But what if you don't have a table? What if you're just looking at a graph? Well, there's an even faster test for that. And here's the one single, non-negotiable rule you have to remember. A direct variation graph has to be a straight line, and it must pass right through the origin. That's the point, 0, 0. So let's look at this example. It's a straight line, which is a good start. But look really closely. Where does it cross that vertical y-axis? It hits at the point 0, 1. It doesn't start at 0. And because it fails that one simple rule, it is not a direct variation. Case closed. All right, so now we know how to identify these things from tables and graphs. That's awesome. But the real power, the reason we care, comes when we start using this knowledge to find missing pieces of information. This is where it becomes a really powerful problem-solving tool.
So here's a classic kind of problem you'll see. It tells you right up front that y varies directly as x. That's our big clue. Then it gives you one complete set of information and asks you to find a missing piece of another set.
And just like before, there's a really simple two-step plan to solve this little mystery.
Step 1, find the secret code, k, using the complete pair they gave you. Step 2, use that code to find the answer you're looking for.
Let's do it. Step 1 is to find k. We use the pair we know. Y is 10 when x is 2. So we just divide y by x. 10 divided by 2 gives us 5. Boom. We've just found the rule for this entire relationship. Y equals 5x.
Now for the easy part. Step 2. We use our new rule to find the missing y when x equals 5. All we do is plug that 5 into our equation. So, y equals 5 times 5. And our answer is 25. See? Once you find that secret code k, the rest is just simple multiplication.
Now really quick, let's talk about a couple of common traps to watch out for. First, if you see any addition or subtraction, like in y equals 2x plus 1, it's immediately disqualified. That plus 1 messes everything up because it means the line doesn't start at 0. It has to be strictly multiplication. And second, always remember that k is y divided by x. Don't accidentally flip it around.
So why does any of this matter outside of a math class? Well, currency exchange is a perfect real-world example of direct variation. The exchange rate is your constant, your k. And think about it. If you have $0 to exchange, how many euros do you get? 0, of course. It passes the origin test perfectly.
So if you take just one thing away from all of this, let it be this simple idea right here. Direct variation boils down to two fundamental rules. You have to start at 0, and you have to grow or shrink at a perfectly steady, constant rate. That's the whole game.
And that, of course, leads us to a fantastic final question. We saw that one graph earlier, the one that passed through 0, 1. It was a straight line, it had a constant rate, but we said it wasn't a direct variation, so what is it then? Well, that's where things start to get even more interesting, and it's the perfect next step on your algebra journey.